Hello everyone, welcome back to Blackbirdhub. This is Venkat, and in this video, we'll be continuing over the topic of inheritance, discussing about contracts and interfaces in detail. So let us begin. Discussing about contracts, these are some specific expectations and obligations to which every class must adhere to. It makes it possible telling what exactly or which certain methods and fields should be exposed from one particular class, the owner class, to the other member classes. Now, in Java, a contract is specified by the use of interfaces. So, for example, if human is an interface, then the contract it defines is to eat, breathe, and sleep, and etc. So, every class implementing this human interface should follow the contracts specified by the interface. But what exactly are these interfaces? Interfaces are like contracts for classes. Until Java 8, interfaces could only be used to define contracts. It helped in decoupling of the code. It also makes the code loosely coupled and it does not push the implementations higher in the hierarchy of classes. But what do I mean when I say that interfaces decouples the code and makes it loosely coupled? So let me explain this. So we have two scenarios, both of payment processing. Let's say that you want to integrate a payment processor, okay, uh, for Razorpay, just an example. So you want to have a payment gateway, and the payment gateway is this Razorpay. Now what you do is you write the class in order to integrate this Razorpay payment gateway. You create a class which with the name Razorpay gateway, and you write its concrete implementation. So this is a concrete class that you are writing in case of tight coupling. Now, let's say that your company has decided that it wants to switch from Razorpay because of some platform charges that it consumes. And the switch should be to a Stripe gateway using the Stripe payment gateway. Then again, you would start writing a concrete class for the Stripe gateway. Now, in case in the future this changes, even the company wants that, we don't want payment gateway, let's integrate some of our own payment gateway into it. So the company gives you a documentation of their custom implemented gateways. Now, instead of repeating this process of like constantly writing a concrete implementation for each type of gateway, a better option is to create a generic method for all the gateways, which is common for all the gateways, and that is where loose coupling comes in. In case of loose coupling, what happens is you firstly define a contract for a gateway. Now, what does this contract for a payment gateway mean? It simply means to have a method with the name of process payments. This particular method, that comes under the contract for within the payment gateway, would help us to define the implementations for different other gateways that are present in front of you. So be it some custom implemented gateway or be it some Razorpay or Stripe gateway, any of these classes would then be the descendant of the payment gateway interface, and they will have to provide their own concrete implementations for this particular method or for this particular contract. Which one sounds more appealing to you? Definitely the second one, I suppose. If you don't want too much of a burden resolving the gateways with time to time. And that is the reason why we use interfaces and not concrete implementations of the classes present in the class hierarchy. But how exactly would you create an interface in Java? Let us understand this with the help of a code example. So I'm here. Let me create some package. I want an interface. So I'll say interfaces example dot human interface. So I have this human interface, which basically has methods or basically the contracts that it is going to define for the uh, upcoming implementations, and that should be just as we discussed, is to void eat and void breathe and void sleep. And yeah, you don't learn walking right away. So just three methods, I think. So this particular thing that you're seeing is how exactly we create an interface in Java. You might think, why do we have a semicolon after the end of the formal parameter list? This method signature denotes an abstract method. What are abstract methods now? Methods which or whose implementations are to be specified by the implementing classes are known as abstract methods. As simple as that. Let me just put it down here. Abstract methods are those methods whose whose concrete implementations is to be specified by the classes that either extend or implement the interface or the class containing the method. How will you use an interface in your Java program? Once you have created this human interface, now you are ready to create a new class, let's say Venkat. Okay, we should be capital. And in order to specify that Venkat implements the human interface, you just need to write implements human interface. Now you might see an error, and the error is to implement all the methods which are contained in the implement human interface. Once you do that, you basically override all of the methods that are present in the human interface. You can also see that it has been one implementation for each of these methods, and that is present in the Venkat class. You might also see this option that it denotes that this particular method is an abstract method which is being pulled down to this Venkat class via human interface. And now here I can specify my concrete implementations for these methods, and I can say Venkat eats, and then we can also specify Venkat reads, and then for the sleep we can also specify Venkat sleeps. Okay, I mean, not really, but okay. Now, if we try to instantiate Venkat, using a main method, let's say I have a driver class here, um, class driver, public static void main. Within this main method, I instantiate Venkat. Now, if you don't know about this var keyword, please study about this in my videos about data types in Java. I've specified what exactly this var means, and if you don't understand that, then there is no point studying inheritance right now. So I request, if you have not studied, please go to that video here up in the description. There is the link, and study that, and then come back here again. So I can invoke all of these methods. And now if I try to run this, the simple output that we are going to get is Venkat eat, breathes, and sleep. That's obvious. This is how you create an interface and then also use an interface in a concrete in order to provide the concrete implementation for that interface. There's one thing that you should keep in mind, and that is you cannot instantiate an interface. Now, why am I saying this? That we cannot create an object for an interface. This is because the implementations of those particular interface is to be provided by the concrete classes who are implementing those interfaces, or who are adhering to the contracts that are declared by that interface. So this means that interfaces don't have a complete implementation of everything. An interface just specifies what a class must do, but it does not specify how exactly does that class does it. And just for a simple sake of reason, because the concrete classes are supposed to be the ones specifying the exact specific implementations for a particular set of behavior and contracts. With the use of inheritance, you can avoid pushing the concrete implementations higher in the hierarchy of classes. This is the reason why people don't really prefer using abstract classes that much as they do with interfaces. We will soon learn what exactly abstract classes are, but for the time being, just understand that they are classes which are below interfaces in the hierarchy order. The sole purpose of interfaces is to disconnect the definition of a method and the or the set of methods from the inheritance hierarchy. Since interfaces are in a different hierarchy from classes, it is possible for the classes that they are unrelated in terms of the class hierarchy to implement the same interface. I hope that is clear. You must be wondering, why aren't we specifying any kind of access specifiers in front of these methods? Does this mean that they have a default package private access specifier? No, it doesn't. It's because in case of an interface, all methods are public by default. Excuse my throat because it's not in a good condition, but the point being, you don't specify public here just because it is redundant. If you still wish to write, you can write it, but again, then it's redundant, so avoid writing it. So, Venki, tell me one thing. Can we only declare abstract methods and nothing else apart from it? No, that's not true. We can also define constants. Let's say I can define a field as string birth date, and that is to be 1701 2006. So this particular birth date, this field within the human interface shouldn't exactly be the same for all the humans, right? This birth date can vary. Everybody did not born on this day. So what we can do is we can just have this DDMMYY format as a constant. Once we do this, this becomes a final constant, which if we want, we can use without even instantiating the human interface. Now if I try to run the program, the output that I get is this. Again, if you see that if we try to change this somewhere in the interface, we cannot. The sole reason being, when you write this birth date, it comes with some access specifiers which are public, static, and final. So let's say even if you have a default method or a static method, and if you try to change this, birth date is equals, the thing that you'll get is cannot assign a value to a final variable birth date. Just because this field birth date is public, static, and final by default. But how come I'm using this static method inside of an interface? That is made possible through the recent updates that Java has given to us in case of interfaces. So with JDK 8 and 9, we can really have private default and static methods in interfaces. Now let's come back to the presentation and discuss what modifiers do we need to use in order to create an interface fields and abstract methods. The answer being interface defined constants are public, static, and final by default. You don't need to specify any kind of access specifiers after this. This is the by default thing that you cannot change in case of an interface. Then the second thing, interface methods or abstract methods are public by default because at the end of the day, the concrete implementation has to be given by any kind of an abstract class or a concrete class that is implementing the interface. Now let us understand how exactly we will perform decoupling of our program using interfaces. So what Java does is it provides or it helps us to have interface references and access implementations through its reference. It's okay if you did not understand, I'll explain in simpler terms. Right now that you're seeing here is a local variable type inferencing thing. But under the hood, it's this. Now, if you want to create another human being, let's say I'm creating one another snail, and again it also implements human interface, not this one, and then implement methods. So I'll write snail eats, and I'll write snail breathes, and then I can write snail sleeps. Okay, not really, because he's a programmer. Now let me come back to this driver class. So I have Venkat as a concrete object that I'm creating. This particular thing is known as tight coupling. Even though we are using interfaces, this thing here is a tight coupling example. Now, what exactly should we do in order to avoid tight coupling? What you can do is you can replace this with a human interface reference. And now you can say that, we are specifying a human interface where this particular human is Venkat. Now you can use the same instance. Let's say, let's replace the name to obj1. And now you can really assign obj1 to a new human, which is a snail that we just created. And then again, you can use the same thing to call all the methods that are present within the human interface so that snail's implementation comes in. Now, if you see, we first get that Venkat sleeps and breathes and eats, and then it's possible to have Snehal with the same object that we are having. Now, this piece of code is what loose coupling means. Now, it is not anymore, it's not any kind of type coupling. You can use an interface reference in order to access the different implementations of it. And if you see, all when I have Venkat as the instance which is stored in the obj1 object, we get the implementations that Venkat has implemented for the given abstract methods of the human interface class. But when we switch to Snail's instance, we get the implementations that we had specified for Snail. This is the beauty of interfaces. Now let us talk about the types of interfaces that are present in Java. So the first type of interface that we are going to learn about is marker interfaces. What is a marker interface? A marker interface is an empty interface. It does not have any kind of methods, even abstract methods or any kind of methods in general, or it does not have any sort of fields that exists. So what is it used for then? It is used to signal or basically mark a class for special behavior. Used for marking a class with special behavior. So basically, the concept behind this is to flag a certain number of classes for some specific purpose during runtime. And the example of a marker interface that you all must know is the serializable interface. It's quite popular. When we'll learn about file handling, we'll look into the details of serialization and deserializations into and within a file. The usage of marker interfaces were basically for categorizing or tagging that special treatment to some kind of classes by the JVM. Just for a sake of example, the serializable interface denotes that a particular Pojo, that's plain old Java object, is open to serialization and deserialization. Other examples of these kind of marker interfaces are clonable, and there is one more which is remote. The second type of interfaces that we are going to learn about is functional interfaces. And this one is quite interesting. It's a totally different topic in itself. You must have heard about functional programming in Java. Okay, come on, try to act that you did know about functional programming because I think I taught you that when I was discussing about programming paradigms in the second video. Functional interfaces are close to somewhat that. They are a part of functional programming in Java. But what exactly are these interfaces? A functional interface is an interface with exactly one abstract method. So this is a really famous interview question that what is the difference between marker interfaces and traditional normal interfaces, and what is the difference between marker and functional interfaces. This one abstract method makes it possible for the functional interfaces to be used by lambda expressions. So if we have any JavaScript audience, these lambda expressions are basically arrow functions in JavaScript. Okay. The basic need why Java introduced functional interfaces is to provide functional programming features with the help of Stream API in Java. If it wouldn't have been for these interfaces, then it wouldn't have been possible to use lambda expressions at all. In the upcoming near about future, I think within 2 to 3 months, I'd be preparing you all for functional programming in Java as well after we complete generics in this video. Okay, not this video, but in this course. So, what is the purpose of having functional interfaces? The basic purpose of having functional interfaces is to have exactly one abstract method, but it can have multiple private methods and even, let's say, default and static methods. And in order to create a functional interface, you actually need to do these basic things because interfaces at the end of the day. You can not justify that, if my interface has exactly one abstract method, then it's a functional interface. In order to do that, you need to use the functional annotation that is provided by the Java. So that is basically a functional interface. This annotation specifies that the particular interface is a functional interface. Even if you don't specify this, there is not a big deal. It's optional, but it is used for better readability. Just for an example, let's say I have to create a functional interface. Um, Example. So let's say I want to have a addition interface, additive one. So I would write functional interface like this, and the same old thing that we how exactly we create the interface, public interface, and then I specify here calculator. And within this interface body, I would specify that there is a method which is known as int calculate with two parameters, int a and int b, and the implementation of this calculator is to be given there by the implementing classes of these functional interfaces are basically the lambda expressions where we are going to use them. Okay. Some examples of common interfaces are basically supplier, consumer, predicate, function, runnable, and callable. There are even more kind of functional interfaces. We will study about them in great detail once we complete generics. But now I think we should also need to understand how exactly will we use functional interfaces and marker interfaces. So let's come back to this. Let me close these files. and we'll have to create a new file within this. Let's say function dot, okay, function is already a package, so I would specify functional dot, let's say, calculator, which is an interface definitely, and I'll annotate this with functional interface present in the java.lang package. Then I need to have an abstract method, let's say int calculate, int a, int b, and that's it, nothing else. Now that we have this calculator, let us now create a class which would help us implement these methods. That is calculator. Basically, we are providing a very short implementation for this interface. I hope the spelling is right. Yes. Then I can specify two arbitrary variable names and then the addition of them. Now, if I have to use them, I can simply write println calculator dot calculate, and I can specify the values 10 comma 20. How can I forget the semicolon? Now, if you execute this, you will simply get the answer to be 30. Here it is. You can also wish to change the implementations of this lambda expression if you want. This is the arrow expression that we use in Java in order to denote that a particular expression is a lambda expression. And this is the sole implementation for a given method, for a given functional interface. Okay. Now let us understand about the third type of interfaces, that are single abstract method interfaces, or SAM. This means a single abstract method interface. Now, this is yet another name for functional interfaces. The term SAM is used to emphasize the fact that it has a single abstract method and not more than that. So all functional interfaces are SAM interfaces by default. There's no difference in that. Runnable is a good example of not being a functional interface in Java. So I don't think I need to explain much into this. SAM basically has only one abstract method, and all functional interfaces are by default SAMs interfaces. The next type of interface that we are going to study about is a traditional interface that we have, which is basically a normal interface that we just created, the human interface, right? These kind of interfaces are pretty common, and you use these kind of interfaces in day-to-day life. So it can have multiple abstract methods, and it can have numerous number of constant fields or anything that you call. So it can also contain private, default, and static methods as well. The usage of these kind of interfaces is limited to defining the contracts for classes. And since we are talking about contracts, I should specify that you can denote a contract using these kind of interfaces only. So these are used to specify contracts for their implementing classes. The next type of interface that we are going to study about requires a modification and upgradation from Java 8. These kind of interfaces are not available in Java 7. You need to upgrade your version to either Java 8 or versions beyond Java 8. So, what are the changes that have been introduced with the Java 8 JDK 8 update? with respect to interfaces. First change is to have default methods. Now, these default methods are important. Why? Because although interfaces can traditionally be used to specify contracts, you sometimes would want to have an interface specify a particular implementation which is common for all the implementing classes. And that is the reason why you should be having default interfaces, default methods in interfaces. So, for example, let's say you have a interface flyable, denoting that a particular living creature can fly. So that interface should definitely have this default feature, default behavior for that particular creature, whosoever is implementing this flyable interface, that it would be flying. So if I print, it should fly. The implementations of this particular interface should be able to fly, and that is why you use default methods in case of interfaces. They allow the interface to evolve over time without breaking the existing implementations. With the introduction of Java 17, which is which was an LTS, I mean it's still an LTS, but JDK 22 and 21 have overtaken it. You also come to know about the concept of sealed interfaces. What are sealed interfaces? If you have any idea, pause this video and think about the word sealed interfaces. Why exactly is this word sealed used? I hope you have thought about it now. Let us match our answers. Sealed interfaces are introduced in JDK 17 as a part of sealed classes and interfaces, and it restricts other interfaces or classes that can implement it. So Java 17 has brought about a lot of good features, a lot of good things incorporated within the JDK. Java 17 brings in the concept of controlled inheritance. Mind the word. You can control which particular interface can be accessible to which particular class, and which particular abstract class would then be accessible to which particular like the concrete implementation classes. Just for example, in order to understand why it is needed, let's say that I have a shape interface. Shape is an interface. Then I have some classes like rectangle, I have square. Okay, these two are the classes that I have which would implement this shape interface. Okay, but let's say there is an intern developer who has joined, and there is a human class, or let's say a better word would be a user class, Pojo, which implements this shape interface. How stupid that is. Try to understand. So, being a senior developer, you won't sit back and fix this kind of bad code. You should know which particular interface is meant for which kind of implementations. If it's a shape, then it has to be a 2D or a 3D geometrical figure. But if user also tries to implement this shape interface and provides false implementations for the methods contained within this interface, what will happen is the quality of code and the logic of your entire application gets fucked up. In order to fix that, you use sealed interfaces. This allows you to specify what concrete classes or abstract classes can basically implement the shape interface. How exactly you do it, let us see now. So I'll say a new package, sealed, and let's say shape. So this has become a class. I'm sorry, this should be an interface. Right. Now let's say this has some sort of double area, and it has some sort of a perimeter. All right. So it has an area and it has a perimeter. Now let me say that I have a class, a rectangle, which implements the shape, and it implements and provides its own implementation of these methods. And I have another class. I have another class in the square. Okay, just a second. I need to create one. Saying square and also implements shape. Okay, well and good. Now let's say an intern joins and he creates a user class, and he implements this user class. He implements the shape. Now, syntactically, there is no problem. You can implement the methods, but logically, think about this. Can a user have some sort of an area and perimeter? It's impossible. So, as a developer, as a good developer, what you do is you specify that this interface is sealed and it only permits rectangle and square. It does not permit user. We see some kind of errors, that is, make all sealed classes, subclasses either must be final, sealed, or non-sealed. Using final keyword, what it does is uh, it basically says to the compiler that there are no other implementation of this particular square class. There are no abstractions for this square class. This is the final and the concrete implementation. And now if you come back here, you see sealed class must permits clause must contain all subclasses. So now the intern must be getting some kind of an error that the user cannot implement this shape class, and it cannot override all of these methods as well. Now if you come back here, you see there is no error. This mind-blowing feature has been introduced within Java 17. There is another thing that you can use, and that is the another type of interfaces that exist is the nested interface. You can basically have multiple interfaces within a parent interface. So these are useful when interface is strongly tied to a specific class or it belongs to a group of related classes directly. With the introduction of Java 9, there was this update in the interfaces that was you can also have private methods within an interface, allowing reusability between the default and static methods. So, static and private methods can also be created in interfaces from Java 9 and above. With the use of private methods, you can perform reusability within the interface itself at the interface level. Private methods are definitely not accessible outside of that interface or basically the constructor defining them. And with the help of static methods, you don't have to take the pain of writing an implementation for that particular interface and then invoking that particular method. So these methods basically provide with code like reduction of code duplication and also reusability at an interface level. So these were the things that we had to discuss for this video. What we had discussed are contracts, interfaces, all the types of interfaces, the feature updates that we have at our exposure, and in the upcoming videos, we will be talking about abstract methods, abstract classes, and methods in Java. We'll be studying about what exactly abstract classes are used for. We would be creating some of them. We would be writing the implementations of abstract methods, and so on and so forth in the upcoming video of inheritance. We'll also be discussing a little about composition and aggregation in the same video. Also, we'll be talking why general inheritance is flawed. So, we'll also talk about this. Something that we also will love to talk about is the use of interfaces and abstract classes in real life. So, I'll talk about this dependency injection and version of control in the next video. Till then, thanks for watching. And if you haven't subscribed the channel, please do that. It takes a lot of efforts to make these videos. Thank you.